Hey, good afternoon, everyone. My name is Paul Erubami, and I'm happy to be with you again today for another lunch hour learning session. Last week, we had the second part of our, talk on sustainability. And even though we have spent quite some time talking about energy as part of sustainability, we also think it's important to have a special dedicated session for just energy management. This is because energy management is the most important aspect of sustainability, but more important because it's a substantial, part of our cost of operations as facility managers. And with the cost pressures we are all going through, we cannot overlook sustainability and the implication of energy in achieving that. So today, we're going to spend this hour purely talking about energy management. Last week, we had a high impact session of our training from Tuesday to Friday, 4 days. And that was a special package we had for the eHealth Africa group. We have another high impact course for facility management operations coming up on the 7th and 8th of November, which is just a few days away. So if you haven't, taken an FM training this year, this is probably the opportunity, the last one you can have to learn for 2 days with our expert team. It's just 45,000 hours, so that's not very expensive. And all you need to do is just, go to our website, register for the FMO class at Max-Migold.com/FMO or facilityManagementCourses.com/FMO and do your registration, after which you post your payment to the bank and send an email to training@maxmigold.com and you're in. You can decide to take the course, virtually for the 2 days. We're running a hybrid approach, or you can come to our training center at Unila campus from 9 o'clock to 4 p.m. each of those 2 days. For the FM Mastercraft Diploma course, FMMC 23, starting on January 6th, we have announced a series of bonanzas as we build up to that class. Throughout the month of September and October, all those who make payments for the FMMC 23 class will continue to earn 30% off their tuition. We decided to do these 3-tier early bird payments, early bird bonanzas for this course. So throughout the month of November, take advantage of the 20% on offer. And throughout the month of December, take advantage of the 10% on offer. Because as soon as we turn the leaf into 2025, on the 6th of January, we will start the program. So we only have, October, November, and December to finish recruiting for this program. So if you've been thinking about it, please don't think too much about it, because all those who have done it before you have moved on with their careers and have excelled in what they do. In addition to these 3-tier bonanzas that we have just announced, we also have the flexible payment options. You can start paying now, and if you pay up before class starts in January, you can even enjoy 10% discounts on everything. But if you start paying now and you want to do a 2 months, 3 months, 6 months payment plan, you are free to do that, which means for the physical class, you probably just be paying about 125,000 for the virtual class, about 85 or 90,000 or so. So all that details are available on our website. So take advantage of this and refer your friends and those who need the career boost that this program brings to take advantage of the opportunities we've offered. Okay, so time to dive into today's launch hour topic proper: energy management. At the end of this course, we hope you'll be able to understand the importance of energy management in facility operations, identify energy efficient technologies and practices for reducing consumption, optimizing consumption, however you want to put it, because the whole idea is not necessarily to reduce, but to optimize energy use, including the energy use performance metrics. Okay, how to conduct energy audits and assess performance metrics, explore renewable energy options for facilities and their benefits, understand the role of smart technologies in optimizing energy use, familiarize with energy regulations and how to ensure compliance in your facility management operations. I'm going to cover those topics in that order: introduction, energy efficiency tech, renewable energy, energy audits, automated energy management systems, and regulations and standards. So let me start by just talking about sources of energy. Energy is not the same depending on how you acquire the energy. The most common form of energy today available to us in the built environment are the ones for what we call the fossil fuels. The fossil fuels are energy produced from crude oil, produced from natural gas, produced from coal, or any of those minerals that we extract from the earth. So even if you extract bituminous minerals of gas or crude oil or whatever it is, and you burn them for energy, use them as fuel, those are fossil. And then you have the renewable fuels, quite a long list on its own too, from wind, solar, to hydro, to geothermal. We'll talk about this as we go on as well. And then you have the nuclear fuels. This can be gotten from reactions, chemical reactions of fusion or fission of nuclear particles in a reactor to generate energy in very large amounts. And these are very sensitive aspects because it's not anybody that can just deploy nuclear fuels. Okay, so for us, talking about energy management, let's understand as an individual, as someone who manages facilities, or even in your house, the energy you use, do you know where it's coming from? Do you know how it's being gotten, right? It's very important that we understand how the energy is coming in. Sometimes you think about the grid, the national grid, power comes in from those cables up there, plug into our houses, and we use the energy. Have you considered where that energy is coming from as well? Because country like Nigeria, we have several hydro dams, about 3 that are active, Kanji, Shiroro, and what's the name of the last one? We have about 3 dams that are, basically contributing to that central energy pool that we call the national grid. And then we have so many thermal plants. Thermal plants use natural gas, right? So they burn natural gas and use that thermal energy to generate electricity that also adds to the grid. So we have a mix of fossil fuels, basically. There are micro projects here and there for what they call the embedded generation programs, where you have microgrids, small solar farms that harness the solar energy and feeds certain sections. But we don't have the capacity yet to have large solar farms like the types you have in places like Morocco or Egypt, for example, that can be fed, at that scale into the national grid. But that's something we should be looking forward to. So we have a blend of renewable. But by the way, since the chunk of our energy comes into the grid comes from hydro, we can say Nigeria is, to a large extent sustainable when it comes to energy source as a nation. So the biggest challenge we have as a country today is sufficiency of energy. So if we have the grid made up mostly of renewable source hydro, and then backed up with thermal coming from natural gas, it is fossil, but it's still better than burning diesel or any other fuels processed from crude, right? So because it burns cleaner than crude fuels. If we're able to do that, we will have better sustainability in our energy generation and use as a country. But the quantity, the volume of energy produced in our national grid is so small that some estimates consider it as less than 15% of our demand as a country. So imagine having just less than 1/6 of our average demand being produced with sustainable sources. What now produces the remaining 80% of our energy use? Diesel generators. Large producers and large consumers have started changing or converting to compressed natural gas or using natural gas to generate energy, but that's still not not as substantial or significant compared to the amount of diesel and petrol that we burn, or both coming from crude oil as well. So that's a major problem for Nigeria, and that's something that we all need to think about. So if you have the option of going all renewable, then sprint free, get out of the grid, drop your generators, and then you're doing the world a favor. But if that is not the case, optimize your use of the grid, because the grid has hydropower, as part of its production. So that is a sustainable option, better than, so let your diesel generators and petrol generators be the last resort after all else fails. Okay, so that's the whole idea here. Think about what opportunities you can get to claw off part of your load from fossil fuels, like having solar panels to handle certain critical loads, so that once the grid goes off, for example, you don't necessarily feel under pressure to put on the diesel generator immediately, because some of your loads are being handled by your renewable source. So that's one way to start easing into it. And when you set up solar, you also have the burden of storage using batteries, right? So whether it's dry cell, liquid batteries, lithium batteries, maintenance free, whatever brand of batteries, they contain minerals that by themselves, through their manufacturing process and the rate at which they become obsolete, batteries will do 5 years and then you have to replace them, and they are hazardous materials themselves. So there's a lot of poor sustainability or unsustainability involved in storage. So if you have a system that can synchronize the use of the solar energy with the grid, for example. So there's prioritization on using your solar compared to to the grid, so that only when your solar capacity cannot carry more of your load that the grid comes in, and then let your petrol or diesel generator now come as a third level. In that synchronization arrangement, you make a lot of you save money, by the way. You save a lot of money in that process as well. So just talking about renewable energy, I've talked about solar. Solar is the most practicable for us. The next one is hydropower. If you can get water high enough to fall, and the force of gravity pulling that, bringing that water down is used to turn some turbines with some dynamo set up in it and electricity generated from it. That would be fantastic. That's how our Kainji dams and Shiroro and the other dams are currently generating. So that's the next. And then another opportunity we have in Nigeria is the wind energy. When the wind blows, you put free turbines with their wings out there, and it turns it and generates electricity. Turbines are very good for rural arid environments where you don't have too many structures obstructing the flow of wind, because you need wind gushes to get that to work. For geothermal energy, we don't really do much of that here, because that takes advantage of the temperate environment. When you have cold environment, under the soil is warm, and you can run water through that warm soil to produce hot water that you can use as your energy source. Okay, so our main one is the solar, the hydro, and the wind. But then there's something that's also gaining recognition, that's gaining, becoming a repute lately, and that's the biomass. For those of us who manage facilities in swampy environments where if you build a septic tank, you can't do takeaways, for example. If you build a septic tank, you have to be evacuating all the time, and that's a big headache. Biomass or biodigesters have become a new approach to sewage management, where organisms are allowed to consume the fecal matter in our waste, and those anaerobic bacteria also emit methane, some gases that can be tapped, processed, and used as energy sources. All right, so that's something that is also gaining ground around it. In terms of wave energy, tidal energy, not much, and geothermal, not much can we consider, because take the tidal energy and the wave energy, they depend on what happens on the ocean surface. So you have to put some buoys or some bouncy stuff that the ocean waves will keep moving them in that action that turns some turbine and produce energy. You have to have enough pressure, you have to have enough wave consistently for that to be sustainable, and the technology is quite expensive. All right, so you've talked about the source. We know what our energy sources are. It's also important to understand how our energy is being priced. You pay for energy, you need to know, what a kilowatt hour is and how much that kilowatt hour costs, and know exactly what that kilowatt hour does for you. Because one thing that affects people is the ignorance about how energy is built. If somebody turns your AC on for 3 hours and nobody's in that room, for example, do you know exactly how much you have lost? Because that's the whole idea. The AC consumes, say, 1.5 kilowatts per hour, right? And so for 1 hour, or for 3 hours, it's 4.5 kilowatts, because every hour it does 1.5 kilowatts. And so in 3 hours, it has done 4.5 kilowatts hours, right? So 4.5 kilowatt hours, how much is 1 kilowatt hour? How much does it cost you to buy 1 kilowatt hour? When you take the grid, for example, you pay your light bill, you see the bill, the rate is there. Total units divided by, total amount bill divided by total units gives you your rate. So whether it's 200, 150, 70 naira, depend on your band, that thing called band these days. you now know exactly how much a kilowatt hour is costing you. So somebody, and then if you live in, an estate where it's, hybrid pricing, where both rates are meshed together to give you a single rate. Some of you are paying up to 600, 700 per kilowatt hour, because you use a lot of diesel petrol engines to support the grid. If you have the grid, connected. Now, so you know exactly how much that is. So if somebody puts on your AC for 3 hours and nobody's in that room, you can tell exactly how much you just threw down the drain, right? And that's the kind of consciousness that, forms the background or basis for energy efficiency. You cannot manage, you cannot monitor, you cannot control what you don't know, right? So that's the first thing. Understand how much is actually costing you. Now, the area that gets a bit complex, many people struggle with is, when they generate themselves from solar or from generators, they don't know how to compute what that actually costs. There are equipment costs that needs to be amortized, broken down into how long equipment will serve you to get to the point where you can figure out how much an hour costs of using that equipment that you purchased. Alternatively, you can use the lease rates if there are leasing companies that can lease you those equipment like generators or solar setups. How much they lease it for? Work that into an hour and tell yourself, this is how much this costs me per hour. Then if you're managing on your own, you have maintenance costs, you have fueling costs that goes into that production of energy. Once you know that, then your energy producer, your generator or whatever produces the energy that you feed into your facility, always learn to meter it, meter the energy is giving out. Because if you don't meter it, you don't know how many kilowatt hours it is giving out. So you meter the energy coming out of a generator, or you meter the load, that is packing from that generator. Either way, a meter is some energy meter is between the gen and the house. It is from that reading, you know exactly how much kilowatt hours the generator is giving out. Use that to divide your cost per hour of acquiring and maintaining and fueling that equipment. And you end up with how much a kilowatt hour costs. It could be mind-boggling for many people. For some, it's just something we do as part of maintenance. We spend the money, we buy the diesel. We never bring all of these costs together to, compare it with how much it actually costs to know what a kilowatt hour costs. And this is something I think every facility manager should try to have. Know exactly how much your kilowatt hours cost from the things you put in. And this includes your solar. Some people just say, oh, we'll put up solar there, for 20 years, we'll have you definitely have a problem. The solar needs maintenance, the batteries needs replacement. So use those life cycle cost analysis approach to compute and then meter what the solar is giving. Because sometimes you finish installing something of 10 million, 7 million, 11 million, and you really don't know what it's actually giving. You just know that it carries my fridge, it carries my TV and my lights, and oh yes, it does a lot. But how many watts is the rating of those items? How many hours do they run for, during the day when it's coming? And then work that out into the cost you use to acquire the equipment, the maintenance, and everything that goes into it. And you can know how much a kilowatt hour actually costs you. So before you jump away from the grid, because that's the common thing now everywhere, people just want to, get out of the grid, move into renewable. Can you do this computation first, so you don't jump from fry pan to fire? The second warning I always give, and I need to reemphasize this here, is the fact that if you do not audit your energy use to cut out waste and identify areas of inefficiencies in your system, switching from the non-renewable energy source to a renewable one is just, throwing fire more money into the problem. Because at the end of the day, you buy an expensive energy and you will use that money to fund or fuel your waste, which doesn't make any sense. But if you don't have the right numbers, if you've not computed it at all, you don't even know where this waste is happening. So when we talk about energy management, we want you to be able to systematically monitor, control, and optimize energy consumption the way it's used in your facility. Of course, your operational costs will improve. It will minimize waste because you're now conscious. You now see exactly where problems are. And then, of course, all the other sustainability credits, carbon footprints, carbon emission, and all of those things that we'll talk about in sustainability coming. And then, of course, your equipment, your facilities, they tend to they last longer. Why? Because all of those energy quality issues, power factor, fluctuations, spikes that lead to high energy billing, all of them will be taken care of as part of the energy efficiency program you're running. Okay, so think about how that reduces your cost, think about how that increases your profitability as an organization, and think about how that boosts your organization's sustainability credits, And like I said, start by understanding your current energy profile, and you must do an energy audit. You can do on your own, just do a scan of your facility. Simple things like check all the things that consume energy and find out whether they're producing what they're supposed to produce or additional waste is happening. For example, if a light is supposed to produce light and it's also producing heat, right? That is an indication that something is wrong because it's supposed to produce light, not heat. If it produces heat, the heat energy is used to produce the heat that you don't need from the light, and energy is used by the AC to absorb that heat, right? So that in itself is a problem. Or an AC that makes noise. A filter or something is a roller or fan is not working well and it's making noise, right? So think about when you're doing this audit, or you have printers installed and then they idle and then come on and idle and come on or you have water heaters that just stay on and then it comes on and then it goes out later, and these continue to just consume energy around the clock. Observe, everything that consumes energy around you. Then look at your building fabric. Go outside your office or your home or wherever. When the AC is on, everywhere is supposed to be hot outside. Inside your space is cool because you've made it so. Touch your walls, your windows, your doors, your glass, panels, and see if the cooling is affecting or is affecting the outside. If you have a thermographic imager, those scanners, similar to the ones we use to scan for body temperature and the rest, but they are electrical scanners that you can use to scan your windows, scan your panels, to see if something that should be cool is being warm, see if outside that should be hot is also being cold because your AC is on, and on and on and on. There are so many things you can do on your own just to get a sense of whether your facility is wasting energy or not. Now, also understand how energy is billed for your estate, for your property. All over the world, there is, I don't think we've started adopting that in Nigeria yet, where you have dual pricing, daytime and nighttime. And I think it's something that we should start thinking about as a national grid, because the generators produce the same consistent, energy. And if we use more during the day and at night, we shut down most of our production and activities, that means there's inefficiency in the system. What can be done to increase the use of energy at night to create some kind of balance to optimize an efficient use of our generating plants is to have a dual tariff instead of this band A, band C, band B, whatever they come up with. That really doesn't make sense, to be honest. It really doesn't make sense. You cannot feed off an inefficient system and use that as a value to price. It's not been done anywhere else in the world, and it's irresponsible if you ask me. The best approach to it is have dual bands. Daytime rates is this amount, and nighttime rate is that amount. You can even have what we used to have. I'm aware of that. I think it makes sense. If you have a very large consumer having a different rate, right? It means he can afford it. So when you're bringing social concepts or welfareism into the pricing, you can now have those who consume very little. We just have a light bulb and a fan and a fridge and one TV, for example. You want to allow them, use have very little rates so that the electricity is some kind of subsidy for the poor. So that the rich who really acquires heavy equipment and need to burn all that energy should pay a higher rate, just the way we do with our taxation. It would make a lot of sense if we can go that route, right? Instead of having availability bands. Electricity should be available 24 hours. So the failure of not having electricity available 24 hours should not be used as a pricing mechanism, if you ask me. Now, but there's this economically sound strategy that is adopted in most parts of the world. I think we also do that in Nigeria, where if you are a maximum demand consumer, you have your point load or your skipper meter installation, there is expectation that the power authorities or the discos have to increase capacity because you are a disproportionately large consumer around that area where they provide energy for. And the risk of you not taking power or shutting out will mean that they have invested and will not be able to sell. So because of that, they have a pricing mechanism that tends to use a factor of your peak. Your peak drives their capacity up to meet your peak, as well as all the other smaller users around you. So as a large commercial energy user, if you want to manage your energy costs, watch your peak. Find audits. Use your audit metering system to track how much energy you use every hour and know the hour of the 24 out of the 24 hours, day or night, when you use the highest. And this can be during the day for most offices and factories that work during the day. Could be sometime in the early evenings or late evenings for residential estates where more people are awake and all families are together and all the gas cookers and fridges and air conditioners are blasting at the same time. And, so peak might be different for different load profiles or user profiles. As facilities manager, you must know when your peak is, right? Now, what you do in managing this peak, because you want the peak to be as low as possible, is try to ensure that every other load that can be run outside that peak, those peak hours, are not allowed to run during the peak hours. They are moved elsewhere. So that's why we're talking about load shedding and load shifting. During load shedding, you decide certain loads that should not happen at all. And you're not moving them elsewhere. They're not even necessary to happen at the time. So for an office, for example, people are going on break at 1 o'clock to come back at 2:30 or 2 o'clock. And for that hour or 90 minutes, everything is running full blast, right? If you decide to shut down most central air conditioning, most lights, for example, just leave the essential ones for that period. If that period falls on your peak consumption, that is load shedding because you are not transferring that load elsewhere. You're saving that money straight away and you're reducing your peak at the same time. But then there are some other loads that you really need, to run, like pumping water, processing sewage, some laundry activities going in some hotels and the rest. Now, so load shifting is moving those activities away from your peak period. Most of the time we automate how these things run. Pumps will pick up when certain levels it drops to a certain level in the water tank, right? And most of the time that happens during the peak where a lot of people are flushing, many people are drinking water and doing all the things that we do. And more of us are in the office all doing this at the same time. So it drops and the pumps peaks. So instead of allowing that to be the level controls that moves that pump to peak and the boreholes to start pumping, I'll move that automation. I'll change that automation to a timer, right? So make sure I fill up all my tanks in the evening, make sure I fill up all my tanks in the morning, which are off peaks, so that During peak period, I have enough storage, reservoir to run during peak period. So that pumping load is removed. The same thing with sewage processing. Make sure all the processing is done and the holding tanks are empty in the morning. In the evening, process everything and make sure the holding tanks are empty. So in the afternoon, they will, but then understand your use capacity so that you don't go and have less, storage. If you go and have, maybe you have just 1,500 liters of water tank and your pump probably comes up 3 or 4 times during the day, you will never be able to apply what I'm teaching right now, because what that means is that you're going to have a shortage at some point if you stop the pumps from coming on. So first of all, make sure you are metered to understand how much you actually consume of water of any of these utilities. And then you have enough storage in place to hold you through the peak period. And sometimes the peak period may not be too many hours, maybe just about 2-3 hours during the day. To level that and bring it down is something you want to look at. Okay, so let's talk about your appliances. When you go shopping for TVs, ACs, refrigerators, water dispensers, printers, you always get these eco-friendly ones. Interestingly, they are more expensive. And so you're under the impression that they're just using this fat to sell something that is more expensive. Let me buy the normal one at half price or something like that. If you understand your energy costs and you can compute what 1 watt actually costs you, if you have a coffee machine or a kettle that is 450 watts versus one that is 250 or 300 watts, and they can both boil the same 1 liter of water in 7 or 10 minutes, you can calculate to the nearest watts per liter of water. That's efficiency of such a kettle. And if boiling of water is something that happens, rampantly in the space, you might want to tell yourself the difference between the cost of the energy efficient one and the cost of the normal one may be significant enough for me to buy the more expensive one. Do those calculations for your ACs, for your water pumps, boreholes, pumps, air conditioners, everything that consumes energy, especially the things that you mostly will leave running all through, including our lights and our fans. Don't overlook certain, because the time it operates is very key to the energy consumption. Because if it runs for 10 hours, 12 hours, whatever that is, take a structural fan, for example, you're having some toilets, it can just run perpetually for a long time. And you've not taken any time to actually check what the rating is, times how many hours it stays running perpetually like that, to understand the impact on energy consumption. So that is where you start from. Understand your energy costs, understand your operating hours and how long each of your energy load consumers, consuming equipment run for, and use that to compute how much you would save per day, per month, per year. I always like to compute it for up to 5 years for most equipment of machines that can run for that long, because that is how I know the amount that is at stake, that I can use to compare with how much difference it is between buying the cheap normal one and buying the more expensive energy efficient ones. Then you talk about your buildings maintenance, retrofitting old equipment, installing, removing obsolete controllers and machineries and equipment in your facility. It sounds like it's not sustainable to take down something that is still working because of sustainability, right? Because it's like waste. This material is going to go to either reuse or be junked off. Why can't we stretch it? Why can't we sweat the asset? It makes sense. So you have to think about the balance between keep pushing it, right? And have all those extra energy, that all the heating up and the vibrations and the noise it's making, the energy that's costing you, plus the inconsistencies and poor reliability of these equipment and assets as you try to use them. And then if you're able to compute all of that as a loss, you now compute how much it will cost you to replace them for more efficient ones. You can use that to explain to management that you need to do upgrades. Take lighting, for example. It becomes so easy to upgrade to LED lightings now because LED lightings have become so cheap that they're even cheaper than some of the mercury lights or all of the more expensive ones that we use. So it's easy. From your operations fund, you can even save enough to deal with lights change outs. But we don't want to be taking, I want to save on this one, I want to save on that without having a holistic view of what you are doing, because that's where the challenge normally happens. Some people have gotten money to change their LEDs. So they've gone to change their incandescent lamps to LEDs and oh yeah, all well and good. But they were not able to come back to management to say, for that money you approved and for that extra I spent changing out the lights, this is how much I have saved or continues to save on a regular basis. We just want to clap and say, yes, we've done something sustainable, but you need to have the numbers, your baseline numbers and the improvement numbers. You need to have those data because that helps you to, gain approvals, generate momentum and traction, encourage people who are part of the sustainability journey to keep up making progress and so on and so forth, right? So when you come up with sustainability measures, you must have a means of tracking how the ones you have done before has produced results or otherwise. Okay, so those things you are measuring, they help to keep you focused, right? So if I know this is my water use in the past, 1,000 liters is what we use every week, for example, in an office, and we are just 10 of us. That means each of us use 100 liters per week of water. I'm not necessarily looking at the 1,000 liters as the metric. That's not a metric, that's an absolute number. But what I'm looking at is the 100 liters per person per week, right? So every time you do this, per that, you are generating a metric. Because the expectation is that you should focus on reducing those items, those kind of numbers. If I can get my use increase, let's assume I run a school of 1,000 pupils, and that school increased to 2,000 pupils. That's a good thing. My water use should also increase, right? But my water use per pupil should drop significantly. That's the whole idea of efficiency. That's the whole idea of measuring to provide results. Okay, optimizing facility energy use. Think about the big things we talked about, the building fabric, think about the building systems. I've talked about HVAC system, I've talked about electrical systems and so on. Then also think about the micro ones, the small things that we don't pay attention to, like the phone chargers always on in the wall, the TVs always on standby, and so many things, printers always on standby, water dispensers, water heaters, things are just left on for no apparent reason. And then think about the poor maintenance, the things that our maintenance also costs, poor connections, undersized cables, leaking insulation, low power factor, voltage imbalances and deviations. These are all things that it looks minor, but they create a lot of energy loss. There was one estate we're just wondering why, when they just put money in their meters, buy a token of 20,000 or 50,000, before you blink, the money is gone. Before you blink, the money is gone. So one day we have to look at it again and say, what's making this, speedy run of your credits? And then let's gauge, let's measure and see what the voltage, is. And we saw that the voltage was always on the upper bands. And because, power is a multiplication factor, if any of the elements in that formula is very high, your total power or load or your consumption will be very high. So also watch that. So if instead of having 220 volts 210 volts or even 200 volts, for example, you're getting 239 just because it's within 240. It may be safe, you may be able to survive it, your equipment not blowing up, for example, but then think about the cost. So the things we do in our operations, the intelligence we apply also helps in our energy consumption. And then human error, negligence, lack of focus of people who use buildings can create all kinds of energy loss situation. So instead of waiting, for example, for students who are reading in the nights in a large hall, and they've put on those large chillabs on, and they want to leave, they just walk away. They don't really care. Sometimes people leave the offices, they go for field work, they will come back in 5 or 6 hours, but they want the office to be cool before they come back. So they leave the ACs, blasting away. After all, nobody's actually paying attention or trying to catch. So human efforts can be a problem. We do all those orientation, we do all those trying to communicate with people, put all those signs at the back of the door to say, please switch off your lights, switch off your AC before you leave the office, and so on and so forth, hoping that people will always listen. But to move to an advanced approach, it's good to start using technology. Okay, so instead of trying to push and get people to talk and act in ways that will save the environment and save the cost of running your facility, I put automated sensors. These sensors will sense people's presence, using body heat, for example, not necessarily motion, right? So I can know, when somebody is not there. And it's not about me knowing that somebody is not there. It's about connecting that sensor to the controller. So there's a switch that powers on and off the AC. That switch can receive an automatic controller connected to it that is sensing what the occupancy sensor is saying. So whenever everybody leaves, it counts 1, 2, 3, tells this controller to put off that switch. It goes off. When somebody comes in, it senses the person's presence, it sends information to this controller, so put on the AC, somebody's here. So with that, I've removed human error. If I have to go around taking month starting reading of your meter and take month end reading of your meter, I'll make a lot of mistakes just trying to subtract and compute. But if I have an automated energy management system where every socket is automatically metered using sensors, I know, from my phone, from my laptop, I know what's being consumed real time. And I know what's being consumed historically, in aggregate, segregated, whatever kind of analysis I want to do. So I won't need anybody to tell me what's happened. If it's done, energy has been consumed, and then I cannot compute and ask questions like, what value are we getting for this energy that is being consumed right now? You run an event center, when people come to use the hall, of course, you put on all your air conditioners and stuff, and they paid. But then you track that energy management system, and you realize that for several days, when nobody is paying to use the place, energy is being used at probably 0.5 or 6% of the energy that was used when they were there. Who's paying for this one, right? The cleaners used to put on the ACs when they're cleaning. The security guards used to chill out. When you will now ask yourself, what value are we getting from these hundreds of thousands being spent on this cooling at that time? So that's the whole idea that this brings. It gives you intelligence, helps you take decisions that are going to help your organization. So not just save costs, but also help the environment, because those are the two things we're trying to do here. And turning your facilities to become smart facilities have the additional advantage of comfort and convenience. So it's not just energy savings, not just data intelligence, but it makes your facilities more prestigious. Okay, so when you invest in IoT, Internet of Things, sensors and controllers, you're actually boosting the reputation of your organization and facilities that you manage. And then, at an advanced stage, start looking at standards. The ISO 50001 is building energy standards. there are so many other standards that you can start thinking of, because what the standards do is that they form the benchmark or the baseline for assessing where you are, how you are doing, and then deciding on the actions you need to take to move towards global international standards in those areas. And then you can move from there to green buildings, certifications with LEED, with BREEAM, with Green Edge, IFC, and so on and so forth. There are so many things you can do at that advanced stage. But where we are now in our own economy in Nigeria and our professional standing as facility managers is the basics are still lacking. Number one, know your baseline. Your baseline, meter your water, meter your electricity, weigh and know your waste volumes and types, and just understand those baseline. Number two, conduct audits. So identify areas of wastage, areas of poor sustainability that also affect everything else. In addition to cost wastage, they affect environmental impact, toxic materials, discharge to the environment that shouldn't be, and so on and so forth. You do an audit. And then number three, you begin to put in, based on that gap analysis that has been created with the audit, you begin to put in measures, starting from low-hanging fruit, simple things that you can do. People have changed out to LEDs, for example. People have done monitoring of their diesel consumption to know exactly how much diesel they are using. They've calculated how much a kilowatt of hour costs from their generators, and some of those basic things that you need to do to just have full understanding, and then you start taking steps one after the other to have a simple improvement. So the first obvious improvement you are going to see is cost savings. Cost savings. Every cost you save from energy is a direct introduction of profits, and addition of profits to your organization, because it's simple. Take out expenses from your revenue and you have your profit. So the moment you are able to reduce your expenses because you are now more efficient, because you are monitoring, you are using data, and you are cutting out the waste, from the operations, especially in the area of energy, big deal. Profits will increase for your organization, and you'll be the one creating such profit. Know how to report these, know how to document your baseline numbers, know how to report the progress you are making. Yes, so that's our lesson for today on energy management. I'll turn the time now to see what questions you have. We do have questions in the YouTube channel. Feel free to put it there as well. The team member will pick it up and put it out here for us to come and respond to. And if you are not on our facility management training group on WhatsApp, I recommend you join that group. Have good interactions going on there. And don't forget that we have, announced series of bonanzas towards our FMMC 2025, the FMMC 23. Take advantage of this 30%, 20%, and 10% reducing bonanzas or bonuses or incentives to pay early and take advantage of this. And we also have flexible payment arrangement that allows you to pay for up to 6 months, 2 months, 3 months, 6 months, whatever you can afford, so you can get on the program. Okay. And don't forget to follow us on all our social media platforms. This session is live on YouTube, live on LinkedIn, live on Facebook, right? So, and then all of our previous sessions, hundreds of videos are available in our YouTube channel. So spend time getting to learn some of these things, and refer our channels also to your friends. Put positive reviews to draw attention to these platforms as well. Okay, if I see a hand up, I'll recognize you to speak. Let me see what I have on the chat. Do you conduct training on energy audits? Yes, we conduct training on energy audits. Just send an email to service@max-migold.com. I'm putting it on the chat. Service@max-migold.com. Right? So send an email there. Tell us the name of your company and what your objectives, and we'll send the team over for inspection. So we train, and then we conduct energy audits. We also do all of those environmental inspections and reporting and advisory that you need. If you need to look at certain systems in your facility, your air conditioning system, your electrical system, whatever system you think is being problematic for you, send an email to service@max-migold.com, and we'll be there to do a technical audit for you as well. Okay. So the link to join our WhatsApp chat is on the chat. WhatsApp group is on the chat. The link to join our Telegram group, please put that up as well. And then go to facilitimanagementcourses.com and see all that we have on lineup. A hand is up. Benga, you can unmute.
So much for this wonderful teaching. I just want to...
Benga, you can unmute now. Are you having difficulty unmuting?
Yes, sir. Can you hear me, sir? Sir, can you hear me?
I see your hand is still up, so...
Yes, sir. Can you hear me? Can you hear me now?
You're unmuted now, you can speak.
Oh my gosh.
Okay, is it me that I'm not hearing? Let me see.
Hello, sir. Can you hear me?
It's like... Okay. Okay. You're not speaking, so I'll just take it that you've had your question answered. All right, so that's it for today. See you again next Thursday, and have a good rest of the week. Bye.